Okay, so that brings us to our last topic for the day, which is acceleration. Acceleration is the change in velocity over change in time. So it's like, how fast are you getting faster? It's like when you're going faster, like you're gaining speed or you're losing speed. That is acceleration. I will also tell you that some of you have heard of the word deceleration. And honestly, I don't even know how to spell the word deceleration because in physics, we don't really use deceleration. If we are talking about something slowing down, we talk about it having negative acceleration. And if it's speeding up, it has positive acceleration. And so sometimes instead of acceleration, we use the words speeding up or slowing down. That's actually what we'll say more than deceleration. We don't really use deceleration in physics very much. And notice here, and I think this was on the velocity, I forgot to point it out, there's a vector above the A because acceleration is a vector. Okay, it's are you speeding up? Are you slowing down? It has a direction to it. And so the change in velocity is final velocity minus initial velocity. Change in time is final time minus initial time. And so that is your acceleration. It's how fast are you speeding up or how much are you slowing down. Okay, so let's look at an example. So let's use this formula. If a vehicle has a velocity of negative 20 meters per second and stops in 4 seconds, what is the average acceleration for the vehicle? So the final velocity, it came to a stop. So its final velocity is 0 meters per second. We're going to subtract our initial velocity, which was a negative 20 meters per second. And we're going to subtract the time. The final time was after 4 seconds. And the initial time was 0 seconds from when we started calculating it. And so if we do this, this comes out with a positive 20 on the top. And on the bottom, we have a positive 4. And so our acceleration in that case is 5 meters per second squared, average acceleration. Let me talk about a couple things there. I was aware that I was being a little bit inconsistent, and some of you were probably picking up on those inconsistencies. First thing I want to talk about just briefly, that is maybe the thing that you were thinking of, is significant digits. So if you have taken chemistry, you know that significant digits is a huge thing in chemistry. They really focus on significant digits. In physics, we don't really focus on significant digits. Yes, they're important. Yes, we need to be aware of them, but it's just not the most important thing in our world. And so on the AP test, they are not going to take off on significant digits. Now, that being said, you should be slightly consistent, and you should be reasonable. Here's where they will take you off. They will take off points if you are doing stuff in your calculator and you give an answer that's taken out to like the 5 and 6 and 7 decimal place. You clearly don't even understand what's going on if you have all those decimal places. But in my mind, I figure that you have had chemistry, you have done that focus, and in physics, we're basically going to keep it to 3 or 4 decimal places. Now, that being said, I could have been a little bit more consistent here. In the problem, they had their significant digits. I could have done that, but I was a little bit sloppy with that. So that's the first thing I want to say. And secondly, they don't take off points on the AP test unless you're just providing way too many. That's one thing. Another thing, let's talk about units a little bit. So velocity is measured in meters per second, and time is measured in seconds. The variable that we use for seconds, we really just use an S for seconds, but I write SEC frequently because if it's just an S, sometimes it looks like a 5. Like if I had 4S, it might look like 45. So sometimes I will use SEC, and then sometimes I'll just use the S. And that's just really a handwriting thing. If they're typing it out, they're going to use just a plain old S. So these are the same unit, so we can subtract them. There we did go. These are the same unit, so we can subtract them. Another thing is, mathematically, if you have meters per second divided by seconds, that's like meters per second, that's that one, meters per second, multiplied by the reciprocal is meters per second squared. Okay, so that's where that unit is coming from. We will do quite a bit with units, but again, I'm assuming that you've done some of the units in your chemistry classes, but we will talk about unit conversions in this class as well. And so when we talk about acceleration, sometimes we call it meters per second squared, but sometimes it actually makes more sense to call it meters per second, because remember, it's change in velocity. So there's your velocity. How much is your velocity changing per second? Okay, meters per second. So either meters per second or meters per second squared, they both mean the same thing. You ought to kind of understand where acceleration comes from. Meters per second squared comes from it's changing 5 meters per second every second. And the last thing I want to talk about here is the signs, the negative and positive signs. So the original problem had a negative in it. And remember with slope, like the main one that you learn for slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. When I teach it, I usually say, you know what, you can go either way. I don't really care which one's your first and your second, as long as you're consistent on the denominator with the numerator. So you could have written it this way. You will come up with the same answer, because this is going to be, let's say, a negative over positive. Well, this one's going to be a positive over negative. Your final result will have the same sign. Okay, so let's think about what's going on here. Here we had the final, they'd stopped, minus the initial. What does this negative 20 meters per second mean anyway? Well, it means that that car is going in the negative direction, whichever way you want to say is negative. So here's the car, and it's going negative 20 meters per second. It's going this way. That's what that negative means. And it stops in 4 seconds, and yet our answer came up with 5 meters per second squared. That is a positive answer, right? Boy, this is going to take some time to get through. I'm not going to get through all of it in this video, because what that means is it has a positive acceleration. It was going in this way, but then something is acting on it to make it slow down. And so the acceleration, that's the acceleration that's acting on it to make it slow down. So the acceleration is actually in the positive direction because the initial was in the negative direction and it came to a stop. That's a lot, and we'll talk about that later. But that's why that answer of being positive does ring true, because the initial was a negative initial velocity. Okay, that's some very, very basics on some of the basics of kinematics.